Okay, we're going to continue to look at some quadratic equations. And last time we solved some quadratic equations which involved finding, first of all, the highest common factor. We're going to just move on from that to ones involving difference of two squares. So let's take down example 1 and see where we go with this one. So x squared minus 16 is equal to 0. Okay, so the first thing that I need to think about is the fact that I'm going to factorise this, and what skills are required to factorise this one. What type of question is this? Well, it's got a difference in the middle, and I've got a squared term here, x squared, and I've got 16. Well, 16 is a square number, since 4 squared is 16, so we can say that that's a difference of two squares. So for a difference of two squares, we've got a technique for factorising that. The first thing that we'll look at, though, is there a highest common factor to take out? And there's not. So if there's not, I'll proceed to difference of two squares. And for difference of two squares, remember, we've looked at this before, bracket or plus bracket with a minus. I then take the square root of x squared to get x, and the square root of 16 to get 4. And that's equal to 0. So now I've got this times this equals 0, which means the first thing could be 0, x plus 4. The second thing could be 0, x minus 4. Okay, bring that over, change its sign and do likewise there, and that would give me x equals minus 4 and x equals 4. So again, what have I did there? I've solved to find the roots. I've got a root at minus 4 and 4, and what might that look like? Well, a parabola with a root at minus 4 and a root at 4. That's actually what's going on there when I solve to find the x equals minus 4 and x equals 4. I'm finding the roots. I've got one at minus 4 and I've got one at 4. Okay, let's try an example 2. This time let's go for g squared minus 25 equals 0. Okay, first move, always look for the highest common factor first. So no common factor, what's next? Well, could it be difference of two squares? Well, there's a difference, and then there's a square, there's g squared, and there's 25. Well, we know that 25 is a square number, that's 5 squared, so it is indeed a difference of two squares. So difference of two squares, let's set up the two brackets. We've learned this before from our factorising work. Bracket or plus bracket with a minus, and then it's the square root of g squared is g, and the square root of 25 is 5. So now I've got g plus 5 times g minus 5 equals 0, so the first thing could be 0. The second thing could be 0. Okay, bring them over, change their sign. G equals minus 5, g equals 5. That's how we think about what that could mean. Well, we've got a parabola, and the roots, remember that these are the roots. The roots occur at minus 5 and 5. Okay, and an example 3. Example 3, let's go for p squared minus 100 equals 0. Okay, so first of all, look for the highest common factor, but I'm not going to find one, so it's difference of two squares again. Okay, so bracket with a plus, bracket with a minus. Square root of p squared then is p, and the square root of 100 is 10. So then we've got p plus 10 bracket p minus 10 is equal to 0. So the first bracket could be 0, the second bracket could be 0. Okay, let's bring these over, change our sign. That would be p equals minus 10, p equals 10. And again, another visual as to what that might look like. Well, we would have a root at minus 10 and a root at 10. And that's what these numbers represent. Okay, example 4. Example 4, we've got 9 minus x squared equals 0. Okay, now we might look at this one and say it's a bit strange because the number comes before the letter. Let's just follow a routine. Highest common factor. We're not finding one, so it's a difference of two squares. Okay, so bracket with a plus, bracket with a minus. Let's just put things in order that we see them. Square root of 9 is 3. Square root of x squared is x. Okay, so the first bracket then could be 0, 3 plus x. And the second bracket could be 0, 3 minus x. And let's just take our time. I'm going to bring that 3 over, it will become minus 3. Okay, I'm going to bring that 3 over, and that will be minus 3. So minus x equals minus 3. Well, that just means then that x equals 3 by dividing both sides by minus 1. Okay, so then just let's have a wee think about what that means then. I've got a root at minus 3 and 3. Now I'm just going to look at this one and have a think about it. And then I'm going to cross that out because in fact it wouldn't look like that. Now I would definitely have a root at minus 3 and 3, that's no doubt. But the parabola wouldn't be this concave down U shape. Now the reason being is because it is a minus x squared. And we've looked and seen before that a minus x squared is not concave down, but in fact it's concave up. So the curve would look more like that. So what we're remembering at that point is a positive x squared gives you the concave down U shape, but a negative x squared like we've got here gives you the inverted U shape. Okay, let's try an example 5. Example 5, 1 minus n squared equals 0. Okay, so no common factor going, but yeah, it's a difference of two squares. So bracket with a plus, bracket with a minus, square root of 1 is 1, square root of n squared is n. So then I've got 1 plus n equals 0, 1 minus n equals 0. Okay, so the 1 goes over, n equals minus 1. The 1 go over minus n equals minus 1. Okay, so I've got n equals minus 1 minus n equals minus 1, which means n would be equal to 1. Again, what's another thing to think about? Well, it's that negative n squared this time. That's the letter that we're using. But the key thing to take out of that is that means it will be concave up. I've got a root at 1 and minus 1. Concave up, and it would look a little bit like that. Okay, let's try an example 6. Example 6, 3x squared minus 27 is equal to 0. Okay, first move, can I take out a common factor? Well, before I rush by that bit, it's important to have a look because in fact this time I can definitely take out a common factor, a numerical common factor of 3. So algebraically, in terms of letters, I'm not going to be able to take anything out because I've only got one letter term here, no letter term here, but numerically from 3 and 27, I can definitely take out a common factor of 3. Okay, so then 3 times what gives me 3x squared. Well, that's definitely going to be x squared. And then 3 times what gives me 27. Well, that's going to be 9, and there's a minus in the middle, so that's minus 9 equals 0. Okay, now there's maybe some potential for this 3 distracting me a little bit. So let's do some of this balancing equations thing. So if I do the same thing to both sides, then that's fine. So I could divide both sides by 3 here, and that would cancel them out. And then 0 divided by 3 would still be 0, and that would then leave me just with a slightly simpler equation in terms of how it's presented of x squared minus 9 equals 0. So remember that that's just balancing equations. So as long as I do the same thing to both sides, so I've divided that side by 3 and divided that side by 3, so I've kept things legit. So 3 divided by 3, they go, leave me with x squared minus 9, and 0 divided by 3 is still 0. Okay, and that is now definitely a difference of 2 squares. So let's proceed with that. So it's going to be bracket with a plus, bracket with a minus, and the square root of x squared is x, and the square root of 9 is 3. Okay, so first bracket could be 0, second bracket could be 0, x plus 3 equals 0, x minus 3 equals 0. Okay, bringing them over, change your sign, x equals minus 3 or x equals 3. So what might that look like? Well, concave up or concave down. First of all, well, it's a positive x squared, so it's going to be concave down. And I've got a root at minus 3 and one at 3. And it might look something like that. Okay, let's go example 7. And 2q squared minus 32 equals 0. Okay, first move, look for a highest common factor, and there is one, there's 2, so I'm going to take out that common factor of 2. And 2 bracket q squared minus 16 equals 0, is that right? Let's check. 2 times q squared, 2q squared. 2 times the minus 16 is minus 32, that's fine. Okay, I can then do that thing where I can get rid of that 2 by dividing both sides of the equation by 2. They'll cancel out. And 0 divided by 2 is 0, so that's now q squared minus 16 equals 0. Okay, so I can then do the difference of 2 squares. So there's my difference. There's one of the squares, second square. Bracket with a plus, bracket with a minus. And it will be q plus 4 bracket q minus 4 equals 0, q plus 4 equals 0, or q minus 4 equals 0. So that will give me q equals minus 4 and q is equal to 4. Would this one be concave up or concave down? Well, it's a positive q squared this time, so it's concave down, and I've got a root at minus 4 and 1 at 4, so it might look something like this. Key thing to remember is that I'm solving to find roots. So that's that root and that root there. Okay, let's try an example 8. Example 8, and I've got 2c squared minus 18 equals 0. Okay, first move, I can take out a common factor of 2, so that will be 2 bracket c squared minus 9 equals 0. I can then get rid of that 2 by dividing both sides of the equation by 2. So that leaves me now with just c squared minus 9 is equal to 0 divided by 2 is just 0. That is now a difference of 2 squares. Bracket with a plus, bracket with a minus. And the square root of c squared is c, and the square root of 9 is 3. So c plus 3 bracket c minus 3. Okay, so this times this could be 0, so the first thing could be 0, c plus 3, or the second thing could be 0, c minus 3. Let's solve that. Plus 3 goes over, becomes minus 3, c equals minus 3. Minus 3 goes over, becomes 3. Okay, so what might that one look like? Well, again, it's a positive c squared, so it's going to be a concave down parabola. And a root at minus 3 and 3, and it might look like that. Okay, let's try one more, which is this one, 2x squared equals 8. Okay, first point to note is that every quadratic equation we've solved in the last 15 minutes or so, and in the previous lesson, was that we always had the thing being equal to 0. We can see this time that it's equal to 8. Well, the first move that we must make there is we need to manipulate the equation, rearrange it so that it is equal to 0. Now, it's just a simple case of moving that 8 to the other side, and it changes its sign to become minus 8. So it's a really simple step, but it's a really important step. So you want to have the equation equal to 0, so you need to bring things across. So the plus 8 needs to come across, become minus 8, which just leaves nothing there. And now we can proceed with the next bit, which is the highest common factor of 2. 2 bracket x squared minus 4 equals 0. Let's just check if that's correct. Well, 2 times x squared is 2x squared, and 2 times minus 4 is minus 8, so that is correct. I can then divide both sides of the equation by 2, which is fine. I'm keeping the thing balanced by doing the same thing to both sides. They two cancel out. And now I've got x squared minus 4 is equal to 0 divided by 2 is 0. That is now a difference of 2 squares, bracket with a plus, bracket with a minus, and the square root of x squared is x, and the square root of 4 is 2, so that's x plus 2 bracket x minus 2 is equal to 0. So x plus 2 equals 0, and x minus 2 equals 0. Okay, that'll be x equals minus 2 and x equals 2. Okay, so positive x squared, concave down, and I've got a root at minus 2 and a root at 2.